Hello everyone, welcome to attend our class. Today we are going to study section 6.5, Constitution and Characteristics of Fillet welds. In section 6.5.1, we will study the constitution of fillet welds and section 6.5.2, Mechanical performance of fillet welds. The cross-section of right fillet weld is usually equilateral right triangle. In a structure subject to direct dynamic load, the unequal right triangle fillet welds are recommended. A weld with the angle of the two edges unequal to 90 degrees is called a bevel fillet weld. The bevel fillet welds are generally used in T-joint, steel funnels, and steel pipes connections. The foot size of the fillet weld cannot be too small, otherwise it will lead to fast cooling after welding, which may result in some cracks in base material. The minimum size of fillet weld foot is closely related to the thicknesses of base material. After welding, the shrinkage stress is caused by cooling, and the larger the size of the welding foot is, the larger the shrinkage stress will be. For fillet weld on the edge of the plate, when the thickness of the plate is more than 6 mm, it is not easy to weld full thicknesses according to the welder's experience. So the foot size of the fillet weld HF should be 1 to 2 mm smaller than the thickness of the plate. When the thickness of the plate is less than 6 mm, small electrode is usually used for welding, and this time the foot size of fillet weld should be smaller than the thickness of the steel plate. The fillet weld is not reliable when its foot size is large and its length is small because of serious local heating of welding parts and other possible defects in welds. In order to enable the weld to have a certain bearing capacity, the calculated length of the side fillet weld or the front fillet weld should not be less than 8 times HF and 40 mm. And the calculated length of the weld equals to the weld length after deducting the length of arc indentation and arc retracting. In order to avoid excessive reduction in connection strength, the length of each side weld should not be less than the distance between the two side welds. When two side fillet welds are connected at the end of the plate, the bearing capacity of the connection is related to the ratio of B to LW. B is the distance between the two side welds, and LW is the length of the side weld. When B over LW is bigger than 1, the bearing capacity of the connection decreases, obviously, with the increase of B over LW, which is mainly caused by the uneven distribution of stress in the member due to excessive bending or stress transfer. The stress on the front fillet weld is complex. The normal stress and shear stress exist on the cross-section, and the stress concentration is very serious at the weld root. There are two main reasons. One is the bending of the force line. Second, the welding root is exactly the end of the two welding parts' contact surface, which is equivalent to the tip of the crack. The stress of front fillet weld is mainly normal stress, so its stiffness and strength are larger, and its failure strength is higher than that of the side fillet weld, but its plastic deformation is worse. A large number of test results show that the side fillet weld is mainly subjected to shear stress, with low elastic modulus, low strength, and good plasticity. The transmission line bends when passing through the side fillet weld, so the stress distribution along the weld length direction is not uniform, showing a state of large at both ends and small in the middle. The longer the weld is, the more significant the stress non-uniformity will be. But in the critical plastic working stage, the stress redistribution will occur, which will gradually alleviate the stress non-uniformity. That is all for this lesson. See you next time.